Hello and welcome to this fifth video of my RC transmitter. On this very first slide I want to give a short summary of the previous video. I've been talking about the hardware I'm using to store configuration data. It's an external SRAM. I've been talking about the device specifics, the data organization and the data management. The data within the integrated circuit are organized on 4K of storage units, and each unit has 32 bytes. The data management consists on two topics. The first one is how it is possible to find an unused storage unit and how the data are laid out in the storage. The first thing can be answered by using a table of 512 bytes at the very beginning of the storage, and each bit defines the used or unused status of a corresponding storage unit. The first 16 bits are always set as used. This is because the table itself needs some space within the storage. The last one is also marked always also marked as used, since on the last page there are some meta informations. The configurations are always beginning with a header. Each header has a next and previous pointer to the next and previous configuration. Then there's an area where the name of a configuration can be stored, and the next pointer to the first tile, which contains the configuration data. Each tile contains a payload which is marked in green, and an area which can be interpreted as a next pointer to the next corresponding storage unit. This time I want to talk about how the application writes in and reads out data and how the controls are done. As we can see here on the left side, there is a cascaded structure. At the innermost part there is the storage itself, reflecting the integrated circuit. Then there is a handler and a manager. The handler takes in consideration how the communication with the integrated circuit is working and how the pages or storage units are addressed and how the data then are actually written in. The manager doesn't really care about how the communication with the storage actually works. He is just interested in storing and retrieving configurations. So we can say that the handler is providing a low-level access, while the manager is doing an abstracted access. And to be a little more specific, we can write it like this. There is an SRAM handler and a config manager. The SRAM handler is interested in data, while the config manager is interested in configurations. The next slide will be departed in the SRAM handler and the config manager, and I'm going to start with the SRAM handler. The first thing that has to be answered is what kind of basic behavior should the storage have. I wanted it to behave like a FIFO. So we take a look into the public area and the functions which are provided by the public area. On the first two slots there is a init function and a get status function. I guess they are self-explaining, so I'm coming to the next functions, and these are the functions which are providing the FIFO-like behavior. They are the push function, a pop function, and the data strobe function. The first thing which comes to the eye is that the push and pop functions are working with unsigned shorts, which are 16-bit, while the SRAM actually is based on bytes. So for each of them, one of the tasks is to do for example, for the push function, it takes the 16-bit and needs to depart them into two 8-bit data words. Before one of these bytes is actually written into the SRAM, they are first written into a write data array, and when the push hits the last index of that array, then the array is transferred to the SRAM. The reason why I do this is that it increases the system efficiency, and plus I'm planning to use the DMR in the future, and that will help if there's just an array that can be transferred. The data save strobe takes in consideration that if a configuration is supposed to be written into the storage, the very last data word most probably won't hit exactly the last index of the write array and wouldn't trigger the transfer process. And to force this process, there's a data save strobe function. The pop function on the other side makes use of a read array, and it more or less works the same way. On the very beginning, a complete storage unit is read out of the storage, and each pop reads the next content from the corresponding index from this read array. Then there is also a simple direct access, and with this access it is possible to address the content of a specific address directly. For example, by putting a byte to an address, you provide the byte value itself and the address, and to get a byte there's just the address provided, and the return value is the corresponding value on that address. As well, there are some controls like get space. It returns the value how many unused storage units there are. Then there is a find free method. We can see it here. This corresponds to the bits I've been talking about on the first slide, which is reflecting the used or unused status of a storage unit. Then there is a feed read stream start page and a free list. For the free list, we can see, of course, there is an argument which defines the list which is to be freed, and there is a second argument. I'm going to explain the second argument later in this video. Then there is a format storage function, and yeah, this is self-explaining. It just formats everything which is within the storage. The feed read stream start page function. Yeah, I'm coming to this a little bit later in this video as well. Now I'm going to step into the config manager. Before starting to design the config manager, there's also a question that have to be answered. It takes a look into the future. Is there only one storage? Currently I'm only using the SRAM, but for example, maybe in the future I want to use the computer to do the configuration, or even interchanging configurations between different transmitters. So of course there's not only one storage, and this brings two aspects into the game. The first one is that there is a need for accessing the SRAM in this specific case, and open the door for additional storages without the need to change the access RP. And I'm going to show how this can be done by using C++ mechanisms. So this is the target, the configuration manager, and to hit the specific case of the SRAM, it just inherits the handler, and so it has specific access to the SRAM. And it also inherits an interface, econfig, and is going to implement this configuration interface. And this makes it safe for future applications with other storage technologies, since the manager implements the econfig interface, and the instance of the manager can be referenced with a variable of the type econfig, and so it can be changed by other instances which making use of other storages. And here we take a look into the class definition of the SRAM config manager. It inherits the econfig manager interface by using the public keyword, but for the extern SRAM handler I've decided to use the private keyword, since I don't want the member functions of the SRAM handler to be accessible from outside the config manager. That would bring up the danger that you can bring the system out of order very easily. At the beginning there are some control member functions from the configuration manager. On the beginning we see an open save and close save config stream, and this is very similar to what you do when you're writing streams on desktop PC programs. Then there's a delete current config, and this is where I want to bring the free list, the SRAM handler free list function into mind. And the second argument I've been talking about, if I want to delete a complete configuration, the second argument is including header, and that means that the header of a configuration is freed and every tile that belongs to that configuration. In case of overwriting a current configuration, the argument is excluding header, and that means that the header is not freed. And the effect is that if a current configuration is overwritten, then if there are already existing multiple configurations and they have a specific order and there's one of the configurations overwritten, the slot is not deleted. It remains in the order it has already been. Then there's a function get amount of configs, which just returns the value of defined configurations. And then there is a load last used config and a store last used config. These are informations which are stored within the meta information page. And for example, when I'm switching on the transmitter and I want the functionality that the last used configuration is loaded automatically, of course I need the information which configuration had been the last one being used. So it needs to be stored and loaded. Then there is a jump to the first configuration data, and this performs the skip from the configuration header to the first tile which carries the actual configuration data. And the active configuration is that one that has been used by switching between the configuration headers by using the previous and next pointers on the beginning. Then of course there are the push and pop functions, which are defining the FIFO behavior, and actually they are just forwarding the access to the SRAM handler functions push and pop. At the end there are some user front-end functions like printing the name of a configuration, set the name, and switch to next or previous configuration. For this live demonstration I'm going to use the transmitter only without a target RC model, because I think that the output on the display should be enough. In a first step I'm going to set up 3 very simple configurations which are only using one channel each. On the first configuration I'm going to make this number dependent to this stick. In the second configuration I'm also going to use stick, but with an inverted direction. And in the third configuration I'm going to use this stick. So let's go to configs and set up a new analog pipe and assign it to an output. Up. And as you can see, the number is now dependent to this stick. When I'm pushing the throttle down, the number increases, and when I'm pushing the throttle up, the number decreases. Okay, this configuration will be stored now. I'm going to set a name. I'm going simply to call it blank 0 and save this configuration. And I'm going to load this configuration, switch off the transmitter and switch it on. Going to the menu point, manage configs, load config, and there's only blank 0 in the storage. Right now I'm going to load it, and the behavior is like before. Okay, now I'm going to set up the second configuration by inverting this the direction. You can see the plus, I'm changing it to 0, this inverts the direction. manage configs, set a name. I'm going to set it to blank 1. I save the config, and this time I am asked if I want to override it or if I want to set a new one. I'm going to store it as a new configuration. Now I'm doing the same thing, switching off and on the transmitter, going to menu point load config, and now we have a blank 1, and the reason why it starts with a suggestion to use blank 1 is because that has been the last used configuration, and this is some of the meta information which is stored to the SRAM as well. I'm going to load the blank 0, and this has been the behavior of blank 0. Pushing throttle down, number increases, pushing up, number decreases. Now I'm going to load blank 1, opposite behavior, pushing down, number decreases, pushing up, number increases. Now I'm going to set up the third configuration, and I said I wanted to be sensitive to this stick. So going to the analog configs, setting it the analog select to 3, and so it's not so boring. I'm going also to add a scaling function, and as you see, the scaling is set to 40% for right and left as a presetting. I leave it like this, and now the number is sensitive to this stick, and also the boundaries of the values are smaller due to the scaling of 40%. Now I'm going to save this configuration as blank 2, save config. Oh no, I have pressed the escape button. Set name is still blank 2. Save config as a new configuration. Okay, now I'm switching off and on to transmitter again. Going to load config, and now we see it's starting with blank 2, since this has been the last used configuration, and then there's blank 1, blank 0, and you can switch them in both directions. Now I've showed that it is possible to store multiple configurations and that it is possible to select between them. Let's say I want to load blank 2, this stick, and still with the scaling function. Okay, now I want to show that it is possible to override the configurations. I'm going to override blank 0, so I'm going to load it. Blank 0. Yeah, throttle down, number increases, throttle up, number decreases. I want this configuration so that the number is dependent to this stick. So I'm going to analog configs and set the analog to select to number 2. Now it has changed its sensitivity to the horizontal stick. I'm going to save it, save config, and this time I choose override. Okay, now again switching off and on the transmitter, going manage configs, load config, and they're still blank 0, blank 1, blank 2. I'm going to blank to load blank 0, and the number is still sensitive to the horizontal stick. Okay, now I'm going to delete blank 1. I'm going again to configs, manage configs, delete config, and here we can choose as well between the configurations. As I said, I'm going to delete blank 1. Now I'm switching off and on the transmitter, configs, load, and as you see, blank 1 has disappeared from the selectable configurations. Let's try let's see that nothing has come in this order. I'm going to load blank 0. It is still sensitive to this stick. And I'm going to load blank 2 as well. Configs, load configuration, blank 2. And it is sensitive to this stick. Currently, as a shortcut, I have implemented the format function when the very first menu step is pointing to this dummy. When I hit the button, the whole storage is formatted. I'm going to do this now. So I hit the button, and now if I'm going to show it. If I'm going to manage configs, and if I want to load one, there's nothing to load. And if I want to delete a configuration, there's nothing to delete. So this have been all the functions of the configuration manager. I have set up multiple configurations. I have overwritten a configuration. I have deleted the configuration. It is possible to select between them, set a name, and it's printing the name. Yeah. Thank you for your attention, and maybe we see you in the next video. Bye.